farmer worth their salt knows that to get a really good harvest, you've got to start by knowing the planet, its weather patterns, its wind systems, its soil, and its water. And that's going to be true of farmers on Mars as well. So today I'm talking to geoscientist and educator Kristina Gustovich about Martian geology. I'm Sarah Gilbreath, and this is the Martian Street Food Society.
My name is Kristina Gustovich. My background is in geology and earth science education, and I'm a middle school science teacher.
Can you tell us about how Mars differs from Earth in terms of geology?
So think of Martian geology like earth geology on the surface, but just extreme. So the highs are higher and the lows are lower. The highest point to the lowest point is a difference of over 19 miles or 31 kilometers, which is just massive compared to Earth. If you were to take the biggest mountain, Olympus Mons, and stick it on the surface of the Earth, it would cover the entirety of Missouri. And the deepest valley would just swallow the Grand Canyon. So in terms of the surface, we have some of the same features, but Earth just looks kind of wimpy in comparison.
Is there a reason for that? Why the highs are so much higher and the lows are so much lower?
A lot of it, I think, has to do with the lack of atmosphere. A lot of our features are shaped by streams and wind and glaciers. Those are things that haven't existed on Mars for a lot of its history, or at least its more recent history. And so there isn't erosion, there isn't weathering on the scale that there is on Earth.
So can you tell us anything about the soil or the regolith that's on Mars?
Yeah, most of it is going to be, as you mentioned, basalt based. It's the same thing that our ocean floors are made of on Earth. It's the same thing that our moon is made out of.
Is that uniform across the entire planet, or does the soil vary from region to region like it does on Earth?
So I think the best understanding we have right now is that it is pretty uniform. However, a lot of Mars remains unobserved, especially firsthand. We have not brought any samples back. But most of the surface is basaltic, which would mean that the loose dirt on top of it would be basaltic as well.
Right. And from what I've read so far, while they don't have the kind of erosion that comes from streams, they do have wind, right? And that wind moves like east to west, not north to south. So that sort of helps to make it more uniform across the planet because there are fewer things blocking it up. Is that true?
Yeah, absolutely. And that uniformity persists up into its atmosphere, which is very thin, but there's a constant layer of dust in the atmosphere as well. So not just across the surface of the planet.
Really? Is that like thick enough to block any of the sunlight, or is it a relatively thin layer?
It can become a very thick layer. Mars experiences pretty extreme dust devils or dust storms. Like the one in The Martian isn't entirely fabricated. So it can temporarily block out sun.
So when we're talking about temperature, obviously Mars can be somewhat similar to Earth temperatures, and it can also be much lower. So can you talk a little bit about the variations of temperature that the surface of Mars sees?
Yeah, this is another way that Mars deals in extremes compared to Earth. So at the equator, sometimes around noon, it's a nice 70 degrees Fahrenheit like it is on Earth. But then the highs, or that's about as high as it gets. It can get down to about negative 195 Fahrenheit. The average temperature is about negative 80 Fahrenheit. It's much cooler generally. Mars in general, you're gonna get less solar insolation than on Earth. And insolation is just the amount of sunlight hitting the surface. Distance from the sun is a factor, as well as its lack of atmosphere, because once the sun does reach the surface, that heat isn't trapped the way that it is on Earth.
It won't be too difficult to accommodate for factors like air pressure or temperature inside the domes, but the light on Mars is another story. This is something that affects not just the crops, but the mental health of the colonists too.
About 60% of the sunlight that reaches Earth is the amount that you could expect to experience on the Martian surface. So think about that. Like if you have lived your whole life at the equator and then you go live up above the Arctic Circle, the sun's at a lower angle in the sky and you're getting less direct sunlight. So any attempt at capturing that sunlight to grow crops, I think you'd really need a lot of aid in the way of technology like a greenhouse in order to be really capturing the heat from that sunlight coming in.
So for the people who will be living on Mars, for the colonists, when we're talking about, like, let's say your example, somebody who just moved to the Arctic Circle, they frequently have to take a lot of different supplements to make up for the sunlight, since sunlight gives us vitamin D that is really important to health and well-being. So for Mars, you would see that being a similar situation?
I could see that being the case for sure. And I grew up in Southern California, and then I moved to the Pacific Northwest. And that's very real. Bring your vitamin D, everyone, when you're heading to Mars.
So not just the soil, but there's also going to be obviously lower gravity and lower air pressure. So how do you think that would affect plant growth?
So if we're talking about bringing plants that are adapted for life on Earth and sticking them on Mars, that lower air pressure is going to affect the way that water is able to move through the plant. So if it's used to having a vascular system adapted for air pressure and Earth's gravity, it's going to take quite a bit of an adjustment to make water move through in a way that keeps the plant alive.
So we've talked about how we can adapt to the environment, but what about the plants? Our crops evolved for life on Earth, so if we wanted to start designing crops for Mars, what traits would they need to have?
One of the biggest barriers to life existing, to life visiting Mars is the radiation. So Mars does not have a magnetic field, another way in which it varies quite a bit from Earth geology. There's no magnetic field, and so you're not protected from radiation from the sun. So whatever plant wanted to grow there would need to be really resistant to radiation from the sun. Second, it would need to be pretty resistant to perchlorates. There's quite a bit of perchlorate. It's a chlorine compound in the soil. So it either ideally not care about it or love it and want to eat it.
Are there any plants that we know of that love it and want to eat it?
Probably not.
Okay.
I don't think so.
So let's talk about the water on Mars. So there, obviously, it's been a very hot topic for over a decade now. There was once water on Mars. There is still ice on Mars. There is still some flowing water. Is that accurate?
There is evidence that there might currently be some flowing water. I would have had water really early in its history. So it's around the same age as Earth. Earth is about 4.5 billion years old. So pretty early in its history, 3-ish billion years ago, Mars might have looked a lot like Earth looks now. There's evidence that suggests some ocean shores. There's evidence to suggest that there are water-soaked rocks. There are minerals that show that's the only way we know how they form on Earth, is being in a water-rich environment. So it's implied that that's the way it must have been on Mars. Its atmospheric exit at some point in the last 3 million years changed all of this.
Do we have any idea what caused that?
Yes, the lack of magnetic field, the cause of all of the problems on Mars. So a low amount of gravity and lack of magnetic field meant that solar winds, so just a blast of pressure and particles from the sun, may have sent its atmosphere off into space. There's also the possibility that something hit it. If a lot of times talking about planetary geology, if you can't explain something, the answer is something hit it. And this might also be the case with the Martian atmosphere. Maybe there was a gigantic impact that produced some bananas amount of pressure that sent this atmosphere off into space.
So the water that is there, which is, to my understanding, mostly frozen and mostly at the poles, is this something that would realistically be something that humans could harvest for drinking or for crop irrigation, or is that pretty much locked?
Bad news is a lot of what you see, those nice white ice caps, is carbon dioxide that is frozen. So we can't use all of it, but there is some H2O in there as well. I think it is a possibility, but there would need to be some sort of harvesting system where you're taking out the parts that you can't use, like carbon dioxide.
And similarly spitballing and thinking big, is there any way to bring back a water cycle on Mars so that it would rain again?
Yeah, bringing back tectonics would be part of this process as well. So this might be our only hope for the terraforming that people speak of, eventually changing Earth or changing Mars into an Earth-like planet. If we're able to have plate tectonics moving the way that they are on Earth, this would also influence the way that that gases are cycled into our atmosphere, and therefore the way that gases are cycled through, or materials are cycled through our water cycle. So I think the two would be a very connected process. Mars is really thin atmosphere, does have some really subtle weather systems that exist inside. It snows, but it snows carbon dioxide. So if there could be a way to replace the gases that are present and change the ratio of the gases that are present in the atmosphere, we could turn them into liquid water.
Okay, so it's not totally outside the realm of possibility.
It might take tens of thousands of years, but it's not a no.
Okay. Okay, and then wrapping up. So we usually think of Mars in terms of like the challenges that it presents, and how much harder it's going to be to live there than it is on Earth. But on the flip side, is there anything that you could think of that might actually be easier on Mars than it would be here?
This dust in the atmosphere makes me wonder about that. Just the suspended particles in the atmosphere. If we're thinking about fertilizing crops, maybe there is a way to harness that. I also think about this carbon dioxide snow that sometimes occurs on the planet. Perhaps there is a way to harness that for the use of crops as well. So like on Earth, when we breathe on a plant, the plant takes that in, and then oxygen. Again, ask a botanist. But but if there is a possibility for the plants to be using that carbon, it could be interesting to see.
So what are our takeaways? 1. Martian greenhouses will need to be designed to shield crops from high levels of radiation. And 2, currently there is little or no immediately usable water on the surface of Mars. This means that colonists will need either access to advanced harvesting and filtration systems or water brought from Earth. As always, if you have any comments on this episode or suggestions for things I should cover in the future, let me know down in the comments. I would love to know your thoughts. Thank you so much for watching. See you next time.